This video will discuss another type of associative learning known as operant conditioning, and also differentiate associative learning from non-associative learning. So you should be able to explain what occurs in fear learning, identify the area of the brain involved in fear learning, and explain how non-associative learning is different. So operant conditioning, if you think back to a 100-level psych course, and the differences between classical and operant conditioning. Remember, in classical conditioning, we were talking about pairing stimuli and changing the behavioral response. In operant conditioning, we have a behavioral response and then a stimuli is presented afterwards, and that changes the behavioral response. So the idea is that a response is followed by a reinforcement, so some sort of stimuli, or a punishment, again a stimuli, and it's either strengthened or weakened depending on the consequences. So a behavioral response followed by reinforcement is strengthened. A behavioral response followed by a punishment is weakened. And a lot of times operant conditioning was a little bit more intuitive than classical conditioning for students. You can think about you brought home good grades, your parents rewarded you with money, you continued to get good grades. You forgot to clean your room, you got your iPhone taken away, you in the future you cleaned your room. You cleaned your room. So operant conditioning is also an associative learning. So here we have a mouse in a maze, and when the mouse gets reinforced with Fruit Loops, there's an increased probability of that behavior occurring the next time. So they're more likely to try to go down this arm of the maze because they were reinforced. That behavior, choosing to go down this arm of the maze, was strengthened. Now here, if a punishment occurs, so they go down this arm of the maze and they get a shock, which is an unpleasant consequence, the next time they're less likely to go down that arm of the maze. So the punishment weakened the response to go down that arm of the maze. So the areas that are involved in the brain is the amygdala, where we talked about the amygdala and that fear learning response in previous videos. So the amygdala is important, especially when you have something like a shock that's being administered. Other areas that are important are the VTA, which is shown here, and the nucleus accumbens. And we'll come back and talk about those a little bit more when we talk about the reward system and dopamine in a later chapter. So the question is are classical and operant conditioning the only way we learn? Do we only learn by pairing stimuli, changing our behavioral responses, or a behavior increases because we're reinforced or decreases because we're punished? No, of course not. So there's also other types of learning like observational learning, latent learning, and then we're going to discuss now non-associative learning. To study non-associative learning, aplysia is often used as an experimental model. It is a slug-like invertebrate, shown here, and it's studied due to its large neurons. And here's just a diagram showing you kind of the way that the aplysia is used to study non-associative learning. So I'm not going to talk about it a whole lot because I have a separate video that I want you to watch. It talks about how the aplysia is a superstar, but I will give you a little personal story. I was super excited a couple spring breaks ago. My kids and I were out at the tide pools down at the Cabrillo Aquarium. And we were walking around and we couldn't see much. We saw a couple sea stars, and then all of a sudden I said, I think my daughter found it first. She goes, "What's this?" And I look at it and I was like, "Ah, it's an aplysia!" And I was so excited. And then we went inside and they called it, instead of a sea slug, they had it called a sea snail. And so I actually asked one of the people that was working there if they were all the same thing and if I had the right name and aplysia, and they were actually pretty impressed that I knew that it was an aplysia. So I just want to help you understand why it's non-associative learning and not associative learning. So when we look at aplysia, we talk about habituation, which is a decrease in a response to a stimulus that is presented repeatedly, and sensitization, which is an increase in response to a mild stimulus as a result to previous exposure. And so, for example, with habituation, you stimulate the siphon, and you'll see this demonstrated in the other video, And what happens is you have these neurons that are stimulating this motor neuron, and then you have a gill response. So this is the normal situation, what it looks like. And so all you have is one stimuli. Well, with repeated stimulation, what happens in the habituated animal is that you have a decrease in the amount of neurotransmitters that's released. So what's learned is the animal learns to decrease the neurotransmitter release because this is a repeated stimuli. It's just like if you're wearing a watch and you have that constant pressure, you don't need to keep responding to it. The sea snail that's sitting out in the ocean in those tide pools and keeps having waves lapping up over it, it doesn't need to keep responding to those constant waves coming. So it learns to decrease its response until something else that has a different feeling comes along. Now, sensitization is the opposite. You'll see that there's an increase in neurotransmitter release, which is happening. And so the idea here is that there's no association between stimuli. It's just one stimuli, and that repeated stimulation causes it to learn.